Welcome to Introduction to C Programming. Today we are going to talk about conditional statements, specifically the if statement. So to start off, let me just explain what conditional statements are. Conditional statements allow a specific block of code to execute only when a specific condition has been met. If the condition is not met, then the code within that block will not execute. If statements are one type of conditional statement. We will talk about another type in our next lecture, which is the switch statement. If statements, the way they work, you can see the syntax of it right here. So we have the keyword if. When we type that keyword inside of our IDE, it's going to turn bold in a different color. In Visual Studio, it turns blue. We then open up a parenthesis. Remember that anytime that we open up one of these symbols, we have to make sure that we also close it. So you see here is my open parenthesis, and over here is my close parenthesis. Inside of those parentheses has to be a condition. A condition has to evaluate to either true or false. In this case, I'm comparing the value of a variable that I've named grade to the number 60. Now, this is just a snippet of code. Somewhere up above this if statement, I'm going to have to have created this variable grade. Looking at the fact that I'm comparing it with an integer, chances are that variable would have been created as an integer and already have a value assigned to it. So possibly I have asked the user what the grade is, or I've created a variable called grade and I've given it a value. Somehow there's a variable, a numeric variable called grade, to which I've already assigned a value. I'm now comparing that to see if it's greater than the integer 60. If it is greater than 60, then I'm going to get inside of this curly brace right here, and you see here's the closed curly brace. All of the code that is inside of that set of curly braces will be executed if and only if the grade, the value of that variable grade, is greater than 60. Notice that this is a greater than symbol. This is strictly greater than. If the value of grade is 60, it will not get inside of that because I'm checking strictly to see if the value of the grade variable is greater than 60. Inside of the curly braces, this is called the block of the if statement, or the body of the if statement. So inside of these curly braces, this is the body. So if the condition which is specified inside of the condition clause of the if statement is true, the body of the if statement will execute. So only if the value of the grade variable in this specific case is greater than the integer 60, then we're going to print out passed. If the value of the grade variable is, say, 55, which is not greater than 60, we will not get inside of that if statement and we will not print out passed. Here is a little sample program. So you can see that we include the standard io.h library. We have to include the standard io.h anytime that we're going to do any kind of input or output in C. We then have our entry point to our program, which is the main function. It has the open and close parentheses. We are not taking any parameters, not passing any parameters into that function. The function does not return anything, which is why we've made it void. We then open the curly brace, and everything inside of this open curly brace down to the closed curly brace here on line 14 is the body of the main function. Line 4, I am creating an integer called num. Line 5, I'm creating an integer called actual num, followed, and then I give it a value, so actual num is 50. I then prompt the user on line 6 to say guess a number. On line 7, I read in the user's guess into the variable num. Remember, reading it in, I say scanf is the name of the function, open the parentheses, open the quotation marks, %d is how I specify that I'm going to be reading an integer, close my quotation marks, follow it by a comma, and then I need to have an ampersand in front of the name of the variable into which I'm going to read that value. So what I'm doing here is asking the user to guess a number, and then I am reading whatever integer the user types into this variable num that I've created here on line 4. Line 8, I'm actually using that variable num. You see that I say if the value of the variable num is less than the value of the variable actual num, I'm going to print out too low. So I'm going to compare whatever the user typed in. Maybe the user typed in 30. If the user typed in 30, I say if 30 is less than actual num, the value of actual num is 50. If 30 is less than 50, what am I going to print? I'm going to say too low. So only if this condition is true am I going to get into the body of that if statement. So here's my open curly brace, my closed curly brace. That defines the body of my first if statement. Now, you see in my code, I'm not limited to only having one if statement in my program. That would make for a lot of really, really boring programs. We need more conditions. So you see here on line 11, I say if the value of num is greater than the value of the actual num variable, I'm going to print out that it's too high. So let's walk through an example here. Let's say that the user types in the number 57. And so we print out to the user, guess a number on line 6, line 7. We read in the value from the user. The user's typed in 57. That goes into the variable num. On line 8, I say if the value of the variable num is less than the value of the variable actual num. Well, num was 57 and the value of actual num was 50. So 57 is not less than 50. I will skip the body of that if statement and I will not print out too low. Instead, I go to line 11. I say if 57 is greater than the value of actual num, which is 50, that is true. 57 is greater than 50. I will execute the body of my second if statement. So I'm going to print out too high. Let's do the other example. Let's say that I have a value 45 is what the user types. So I start off, I print out guess a number. It's sitting there, it's waiting. It's just waiting for the user to type something. The user types in 45 and hits enter. 45 is an integer, it's read into this variable num. So I've now read the number 45 into this variable num from the user. I say if 45 is less than 50, actual num was 50, num is 45. If 45 is less than 50, that is true. I go into the body of that if statement and I print out too low. Then I come down to line 11. I say if 45 is greater than 50, it is not greater than 50, so I do not execute the body of that if statement. We've taken care of the case when I guess a number lower than actual num, I guess a number higher than actual num. There's one more case that I have to handle, which is, that's right, if the value of num is equal to actual num. So let's say that the user gets clever and actually types in 50. So we print out guess a number. The user types in 50 that gets read into that variable num. We say if 50 is less than 50, is it? The answer is false. It is not less than 50. It is equal to 50. So 50 is not less than 50. I do not execute the body of that if statement. I come to line 11. I say if 50 is greater than 50. Is 50 greater than 50? It is not. So I don't execute the body of that if statement either. So I jump over that and then my program terminates. So if the user actually guessed 50, nothing is going to happen. We're missing a condition here. And I'll show you how to add that one here in just a second. But you can see that we're actually missing a condition, which is if the num is equal to actual num. Okay, here are the different conditional operators that we have available to us. We have the less than operator and the greater than operator. You just saw an example utilizing both of those. We also have, if we want to check for equality in addition to less than or greater than. So you see that I have a less than or equal right here. We don't have a less than or equal key on the keyboard like you've got in your math classes. Something like that. We don't have that key or the greater than or equal. We don't have those keys on the keyboard. So what we're going to have to do instead, let me show you that in case you can't see that. Let's see, we don't have these two, the greater than or equal and the less than or equal. We don't have those available to us on the keyboard, so instead we just combine two different characters. We put the less than sign and follow it by the equal sign. So that's how I designate less than or equal, greater than or equal the exact same way. It's just the greater than sign followed by the equal sign. So you have to put them right next to each other. Don't put any spaces in the middle of them, and that is going to be one of our conditional operators. The equal operator. You notice here that the equal operator actually has two equal signs. Can you think of the reason for that? What does one equal sign mean? You already have used this a number of times in the programs that you've written. The one equal sign is called the assignment operator. The assignment operator is how you assign a value to a variable. So we've used that when we've said something like int actual num equals 50. That's the single equal sign that we use there. If we want to check to see if two values are equal to each other, that's going to be using the conditional equal operator, which is two equal signs. Let me emphasize this. This is extremely important, and I'm sure that a number of you are going to make this mistake. Whenever you write an if statement and you're trying to check the equality between two variables, or a number in a variable, or a character in a variable, whatever you're trying to check, if you're trying to check equality, you have to utilize the conditional equal operator, which is two equal signs. If you use one equal sign, guess what? Always true. Because if you assign a value to a variable, that is going to evaluate as true, and you will always get inside of your if statement. So you want to make sure that you use the two equal signs whenever you're checking for equality. If you use the one equal sign, this is the assignment statement. You're going to assign a value to a variable instead. So make sure that you utilize the two equal signs if you're checking for equality. Not equal, if you want to check to see if two values are not equal to each other, use the exclamation mark in front of the equal sign. That stands for not equal. And then the bottom one, the unary not, we will talk about that one more in the future when we get into utilizing Boolean values. And then you can just put the not sign in front of it, and that's going to check to see if it's not true. Okay, so now that we know we have a few more operators available to us, let's modify that program that we wrote in the previous slide. So you see that everything looks the same up through line 13. I didn't change anything there. I still have the num variable on line 4, actual num on line 5. I give it a value of 50. That's the number that we're trying to guess. I print out to the user, guess a number. I read it into that variable num on line 7. I check to see if the value that the user typed in is less than the actual num. If it is, I print out too low on line 9. On line 11, I check to see if num is greater than the value that the user typed in. If the number the user typed in is greater than our actual num, which is 50. And if so, on line 12, I print too high. Now I've added another if statement on line 14, 15, 16. On line 14, I say if num equal actual num. Notice that right there, I used the two equal signs. This is the equality operator. This is not the assignment operator. So I'm going to be checking to see if the value typed in by the user, which is in the variable num, is equal to the value of the variable actual num, which is 50. This is not going to assign 50 to the variable num. Instead, this is going to check to see if they're equal. And if it is, it returns true. If it returns true, it gets me into the if statement on line 14. It's going to execute the print line, which is on line 15. So let's take the example where actual num was equal to 50, since we already walked through the other ones. So now, if actual num is equal to 50, I say guess a number. I read in the number from the user, and let's say the user typed in 50. I say if 50 is less than 50, it is not. I do not get into that if statement, so I'm not going to execute the body of that if statement. The next one, I say if 50 is greater than 50, it is not. So I'm not going to get into the body of that if statement. Now I say if 50 is equal to 50, ding, 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 it is. So I get inside of there, and I print out, you guessed it. Now we actually have a nice little guessing game here, right? It'll actually work. Kind of fun. You can type in whatever number you want for actual num, and then you can have people start guessing it. The only problem, we haven't learned how to loop back up to the top. We'll get there, just a couple more lectures. We'll talk about looping statements, and then you'll be able to write the program where it just continues to loop back up until the user guesses the right number. For now, they're going to have to just run your program again and then guess a different number. Since the number is hard-coded that they're trying to guess, they can just run it again and again and again, and eventually they will be able to find the right number. Okay, else statements. What we have on the from the previous slides is that you can see that I can check to see if some value is true, but if I wanted to check another value, I had to just put another if statement. This is not going to be the most efficient way to do this, because what I know is what in this case here on this slide, you see what I'm trying to do is say if the grade is greater than 60, I want to do something, and if it's not, I want to do something else. Well, I could have written this a different way if I wanted to. If I wanted to write this a different way, so let me show you what we have here. So I could have said something like if the grade is greater than 60, I could have done something, and then I could have said if grade is less than or equal to 60, do something else. This code will actually execute exactly the same way as the code that I have here on the slide. Now, there is one difference though, and the one difference is how the computer is going to execute this. The code that I have on the slide is actually slightly more efficient than the code that I have right here. The reason for it is because the code that I have here inside of TextVet says if the grade is greater than 60, print out passed. So if grade was, let's say, 75, it's going to print passed, and then it's going to come to this if statement and say if the grade is less than or equal to 60, it's going to check 75 against 60 again and say nope, it's not less than or equal, so I'm not going to print that out. In this case here on the slide though, it's going to say if 75 is greater than 60, print passed, and then skip over the else. There's no reason to even look at it because I know that one of those conditions was already true. So then it's going to skip over the else statement. I'm not even going to get inside of it. Now, if the grade was less than or equal to 60. Let's say it was 55. It's going to check to see if 55 is greater than 60. It's going to say no, it's not. And it's going to immediately jump down into the body of the else statement. It's not going to have to check any other conditions as well. So what we have over here in my TextPad document that I just typed up is that we are always going to be checking both of those conditions. We will always check to see if grade is greater than 60, regardless of whether it is or it isn't. We are then going to check to see if grade is less than or equal to 60. So we always are going to be doing two comparisons, whereas on this slide I am always only going to be doing one comparison, regardless of whether it is true or false. So it's a little bit more efficient to write it out this way with the else statement. As far as the functionality is concerned, you see that the output would have been exactly the same regardless, but we have just made our code slightly more efficient by not having to check one additional condition. The syntax of the if-else is that you are going to have an if statement. You have the same thing, open parenthesis, have your condition, close parenthesis, and then you need to open your curly brace. Inside of the body of your if statement, you can type anything that you want, any lines of code at all can go inside of the body of the if statement. So we see here I'm just printing out pass, I close my curly brace, and then I have another keyword else. When I type else, it's going to turn blue. It's going to be a keyword. It's one of the reserved words that we have in C. I then do not have a condition. I don't have a condition after else because else is my catch-all. It is going to catch anything that was not evaluated to true from my if statement. So it's going to get inside of my else statement for anything that where grade is not greater than 60, then it's going to get inside of my else statement. So I don't have any condition, no parentheses right after my else. Instead, I have my open curly brace immediately following my else, and then that is the body of my else statement. I can have more than one line inside of each of those bodies. I only have one here just to simplify the slides a little bit, but I could have multiple lines inside of each of those if I want to. If you have an else statement, it's very important. You cannot have an else statement without a corresponding if. It has to come immediately following the closed curly brace of the body of an if statement. You cannot have an else anywhere else in your code other than the very next line after the closed curly brace of an if statement. That's the only place that an else can occur inside of your program. More than one condition. We have the ability to daisy chain if-else statements. So what we have is say, in this case, I say if the grade is greater than 80 inside the body, I'm going to print out an A. Else, and now immediately after the else, I'm following it with an if statement. I say else, if the grade is greater than 70, then I'm going to execute this. I'm going to print out B. Now, what's really important to note here is that if the grade is greater than 80, it prints out A, but then it's going to skip all of the rest. The reason it skips them, those are all else statements, and I'm going to skip over else statements if my condition evaluated true. The only time that I'm going to get inside of my else is if my if condition was not true. So if for some reason grade was not greater than 80, let's say that grade was 75, I'm going to come here and say if the grade is greater than 80 and its grade was 75, that is not greater than 80, I'm going to skip the body of that first if statement. I'm not going to execute it. I come to my else. Now inside of my else, what do I have? I have another if statement. I say if the grade is greater than 70. Well, if 75 is greater than 70, that's true. What do? Print out B, and then since I got inside of that, I skip over all of the other else's, because as soon as one of my conditions is true, nothing else is going to execute other than the body of that one. So that's kind of the beauty of using else statements in conjunction with ifs. Remember that an else statement has to be lined up with an if, and it has to be the immediately following the end of the body of an if statement. Then we can have an else. So you see this else right here follows this curly brace, which ends this if that I have right there. So here is the same example we've been working on, but this is utilizing else statements in addition to the ifs. So you see line 4 is the same, create my variable num. Line 5 is the same, actual num is equal to 50. Line 6, print out to the user, guess a number. Line 7, read in the integer into the variable num. So I read that in from the user, they type whatever they want. Line 8, I say if num is less than actual num. So if they guessed the number which was less than 50, then I'm going to print out too low, and then I'm going to skip over everything else. I'm not going to execute anything else because immediately following that curly brace is an else statement, so that means everything else is going to be skipped. Not even going to look at it, not check those conditions at all. If the value of num was less than actual num, I'm just going to print out too low, and I'm going to skip the rest. all the way down to the very next line of code after the close of this curly brace right here, which closes my last else. So if there was more lines of code between line 16 and 17, those would still execute, but none of the code that I have inside of the subsequent else statements would execute. Let's say that the number that the user typed in was 55. So I come here and I say if 55 is less than 50, it is not. So I do not print too low. I skip over that. I go to my else statement. I say if 55 is greater than 50, it is. I print out too high, and then I skip the rest of it because I will not get into my else statement. There's no other conditions for me to check. So I skip over that, and then I would go to between line 16 and 17 and execute whatever lines of code appear there. The last case, if the number that the user types in right here is 50, I'm going to say if 50 is less than 50, it is not. So then I jump to my else, and I say if 50 is greater than 50, it is not. So I jump to my else, and I say, you guessed it. So it would print out, you guessed it, if the number that the user typed in was 50, because I was comparing against this variable actual num, where I have the value 50 stored. All right, so now, some of you may be asking, well, can I combine some of those conditions together? Maybe I want to check, like, if the grade is between 60 and 70, then I want to print out a C. We do have the ability to do that. This is just going to have multiple conditions inside of a single if statement. So you can see here that we have two different conditions that we have. We have ands and ors. We also have, those are the two main ones that we have. You can also do not, but we have another way to do that with that not equal to operator as well. So what I can do here is I can check to see if our grade is greater than 60 and if our grade is less than 70. So the way that I do that is inside of my if statement, I open the curly brace. You see here that I say if grade is greater than 60, I followed it by 2 ampersands. There's a reason I have 2 ampersands right there. This is the AND operator. This is a Boolean operator, so I have 2 AND signs there, and I say AND grade is less than 70. What this is going to do is check and make sure that both of those conditions are true. If only one of them is true, then this will not, it will not evaluate to true, and we will not print out in this case the character C. So I need both of those conditions to be true for me to be able to get into that statement. Okay, I just did a quick Google search for Boolean truth tables, and I pulled up here a Wikipedia page on truth tables. So what we can see here are two conditions. So if this is going to be for our AND operator, this first one, logical conjunction. This is the AND operator. So if I put the 2 AND signs inside, which I have right here, if I put those there, this is going to give me an AND. So the only time that I have a true as my output is if both conditions are true. So if P is true and Q is true, then my output is also going to be true. That's the only time that I'm going to get into the body of that if statement. If I use the AND operator, is if both conditions are true. If only one of the conditions is true, either P or Q, but the other one is false, you see that I get a false as the output. Both conditions have to be true for the AND operator to be true. If you just think about this logically also, with the AND operator, I need both of them to be true. Otherwise, if only one of them is true, then the output is false. If both of them are false, you see that I also get a false on the output. So the only time that I'm going to get inside of this if statement, since I've used the logical AND operator, is if both of the conditions are true. If only one is true, or if neither is true, then I'm not going to get inside of that. The OR operator, the way that we do the OR operator is with the 2 pipes. The pipe key is on the same key as the backslash key. On a lot of keyboards, it's immediately above the enter or return key. You have to do shift followed by the backslash key, and that will give you the OR operator, the pipe. So 2 of those is the logical OR. So the 2 pipes. With logical OR, what I need is I only need one of the 2 conditions, at least one of the 2 conditions to be true. If at least one of the 2 conditions is true, then my output is going to be true. So here is the truth table for the logical OR. So you see, if P and Q are both true, then I get a true on the output. If P is true but Q is false, at least one of them is true, I get a true on the output. If P is false but Q is true, that means at least one of them is true again, I get a true on the output. The only time that I get a false is if both P and Q are false, and then I'm going to get a false on the output. Taking a look at this, I'm going to try to keep this one up here just for a little bit. Let's keep this AND one up, since that's the one that I'm showing here on the screen right now. I'm going to throw this over here for just a second. The reason I'm going to do that is to show you that these are the logical operators, not the Boolean operators. These are the logical operators that I have right here. Okay, so the Boolean operators, which are just the single and the single or, compared to the logical operators, which are the double and the double or. The difference between a Boolean operator and a logical operator is the logical operator is going to optimize the execution just slightly. Here's how it's going to do it. So looking at the AND operator, we know that both of those conditions must be true for us to be able to get into that the body of the if statement. So if that first condition right here, if grade greater than 60, let's say that the grade is 55, we know that the first condition is false. Well, if either of our conditions is false, so we look here, we see here's if one of them is false, here's if one of them is false, here's if one of them is false. You see that the output is always going to be false. So with the logical operators, if the first condition is false and you're doing an AND, you don't even need to check the second condition because you know the output is going to be, that's right, if either one of the conditions is false, you know that the output is also going to be false. So with the logical AND operator, if the first condition is false, we don't even need to check the second condition, so we won't. If you changed it instead of using the double ampersand and you only use the single ampersand, which is the Boolean AND, the Boolean operator, if you did that, then it would always check both conditions. You don't often need that. Occasionally you might want both conditions to be checked for some reason, but if you don't need that, you want to optimize your code slightly and use the logical operator. Now, with the logical OR, let me scroll down to that one here. Here's the logical OR operator. Now, what we know with the logical OR is that if either condition is true, we know the output is true. So that means that if this was an OR instead of an and that first condition was true, there's no reason to even check the second condition, because if the first condition is true using a logical OR, then what do we know? The output is also going to be true. We don't even need to check the second condition because true or true is true, true or false is true, false or true is true. Those are all true. So if either one of the conditions is true, we don't need to check the second condition. So what we do is if the first condition is true and we're using a logical OR, we will optimize our code slightly and we will not have to even check that second condition. This is something that the compiler does for us. That's the logical operators. So you see that those are going to be slightly more efficient. If, on the other hand, you use the Boolean operators with the single ampersand or the single OR, your code is going to behave exactly the same way. You're going to get the exact same output. The only difference that you're going to have in this case is that you will always be checking the second condition even if you don't need to. So your code will be slightly more optimized. Now, let me give you a little caution here that there are going to be some other things that we talk about in the future, such as the pre and post increment and function calls. When we start getting into those, and if you use those in the conditions of your if statements, then the Boolean operator could possibly behave slightly differently than the logical operator. When we get to the pre and post increment and we get to function calls, I will explain this a little bit more and explain how the Boolean operator will operate slightly differently than the logical operator if you use those inside of the conditions of your if statement. Alright, so let's take a look at some code here now where we are going to be using combining some conditions. So this is the same program we've been working on. The only difference that I've done here is line 8 has changed slightly. So now, not only is line 8 going to check to see if num is less than actual num, but it's also going to check to see if num is greater than actual num. The reason that I use the OR operator there is that I want to see if num is less than actual num or if num is greater than the actual num. The only thing that I'm not checking is if num is equal to actual num, which is when I'm going to get into my else statement. So if the num is less than actual num or if it's greater than actual num, I'm going to print out that's not right. Otherwise, I'm going to print out you guessed it. The reason that I use the OR instead of the AND, if I had used the AND operator, I would have never gotten to line 9. There's absolutely no way that I can ever get to line 9 if I use the AND operator, because num can never be less than actual num and greater than actual num at the same time. It can only be strictly less than actual num or strictly greater than actual num. So I had to use the OR operator. If, in this case, the number that the user guessed was 45, I'm going to say if 45 is less than actual num, that is true. And I know that true or anything is true. So I'm not even going to check the second condition, and I'm going to jump into my if statement. Line 9 will execute saying not right. If the number was 55, then I would come here and say if 55 is less than 50, it is not false or anything is actually anything. So I have to check the second condition and say is 55 greater than 50? It is. That's true. False or true is true. So I get into my the body of my if statement. I will print out not right. The only time that both of those conditions will be false is if actual num is equal to num. So if the user typed in 50 for num, I would say, is 50 less than 50? No, it's not. That's false. Or is 50 greater than 50? It is not. That is false. False or false is false. I will not get into my if statement. I'll jump down to my else statement and then print out, you guessed it. If you didn't catch the truth tables, you didn't catch the how or and works, go back, watch that section again. It's very important that you get the logic down a little bit. You probably will be taking some other classes. If you are some kind of an engineer, you'll be taking some other classes, especially electrical engineers, where you'll talk about Boolean logic a lot more, and you'll talk about gates and how this actually works with voltage levels coming into different gates so that you can have Boolean parameters inside of your hardware with AND gates and OR gates, and you have a couple other gates also, NOT, NOR, NAND, and so on, in Boolean logic. So you'll be covering this in some other classes also, but it's important that you understand just the logic behind it, and the only way that we can get a value of true using an AND operator is if both of the conditions are true. The only way that we can get a true with the OR operator if either of the conditions or both of the conditions are true. There are some very, very sophisticated conditional statements where you can have multiple conditions inside of there, and you can do some pretty cool things with just having the and, or, and those different conditional operators that we talked about on the previous slide. So it can get somewhat complicated. It's important that you understand how all of that works. Okay, single line if statements. The body of an if statement does not need to have curly braces around it if there is only one line inside of it. So you see right here, I say if grade is greater than 60, I print out passed. I don't have the curly braces around that because there's only one line of code inside of that if statement. If there's only one line of code in the body of the if statement, I do not need to have the curly braces. This, however, is very, very bad coding practice. Do not do this. This is not very smart to do that. You want to make sure that you always put your curly braces around the body of your if statements. It works the same way with else statements also, is that if there's only one line of code inside of it, you don't need to have the curly braces around the body of an else statement. The problem that you're going to run into is what I have here in the middle of this slide, is if you write if grade is greater than 60, print out passed, and then you go back to your code, I don't know, a couple days later, a week later, whatever it may be, and you modify to say, oh, you know what, I don't want to just print out passed, but now I want to print out again also. So what's going to happen is that you come here and you print out again right underneath passed. And it looks like the way that I have it indented here is that this printf for again is also inside of that if statement, when in fact it is not. So is this inside the if? The answer to that question is no, it is not. The body of this if statement only consists of this printf passed. It has absolutely nothing to do with how it's tabbed in. The spacing has nothing to do because C is a white space insensitive language. So the tabbing is for us as programmers to understand our code. It has absolutely nothing to do with how the compiler is going to interpret our code. So what's going to happen here is that if the grade's greater than 60, let's say that the grade is 65, it's going to print out pass, and then it's going to print out again. However, if the grade is 55, it's not going to get into this if statement. However, it will still print again, because again is not part of the body of that if statement. If I wanted it to be part of the body of the if statement, I would have needed to put the open curly brace here and the closed curly brace at the bottom. So a good rule of thumb, regardless of how many lines you're going to have inside of your if statement, your else statement, any of those different conditional statements, regardless of the number of lines you're going to have inside, good programming practice, always make sure that you put the curly braces so that you have a body that you can put multiple lines in. Even if you only have one right now, it's going to save you some time in the future if you ever add another line, that you can come in here and you would add it right underneath that printf pass where it would still be inside of that curly brace, and then you would know that it is part of the body of the if statement. Okay, do we put curly braces on the same line or different lines? This is completely up to you. Some people like to put the curly braces on the same line. You see, if grade's greater than 60, I have my curly brace on the same line. That's how I've shown you in this lecture. This is my personal preferences. I put the curly brace on the same line, and then my closed curly brace goes on a separate line all by itself. My motivation for doing that is because I like to be able to see more lines of code on the screen at one time. If I put the curly brace on a separate line like you see right here, now I have an entire line which is more or less blank other than that curly brace on it. However, there is an argument for putting them on separate lines like this. You can see that your curly braces line up. and that you can find them easily. If you have your code indented properly, you can find out very, very easily where this curly brace goes. It goes there. If your code is indented properly, you should be able to also see where this closed curly brace goes, because it's going to line up with the line of code at the top that has the curly brace at the end. I performed a study at one company that I worked at to see whether programmers preferred to put the curly braces on the same line or on different lines, and it was actually very, very close to a 50-50 split. Because we had an odd number of programmers on our team, it wasn't an exact 50-50 split, and the same line curly braces won out, but it was very, very small. It was like 54 to 46%, so it was such a small sample, it wasn't good enough for me to say that we should do it one way over the other. So this is a personal preference of how you prefer to do it. Myself, I like to put the curly brace on the end of the same line, so all of the code that you're going to see that I write in this class is going to be written on this format here that I have on the top. However, if you want to put it on separate lines, there's nothing wrong with that. You won't be graded any differently for that. Actually, most people probably wouldn't even look at you any differently, at least not for that, maybe for something else. Okay, hope you enjoyed that. We'll write a program on the next lecture, so I'll talk to y'all then.